Okay, let's look at number 3. It's going to be quite a weighty question. The first part, A, B, C, D, and E, we're asked to estimate the value of each derivative and then sketch the graph of the derivative of this function, if this is f of x. So I'm just going to do a very rough estimate here. At -2, the graph is actually decreasing, right? It has a negative slope, so I'm just going to estimate that its slope is somewhere around -4. Just an estimate. I know it's negative. I know it's a pretty big number. All right. At -1, let me look at the slope. Well, right here, it's decreasing to the left. It's increasing to the right. So at -1, the slope is actually 0. All right. At 0, the slope is positive. And I'm going to estimate that it's about 1. It's about +1. At 1, the graph goes from increasing on one side to decreasing on the other. Positive slopes, negative slopes. So at that moment, it will be 0 right in between. And at 2, I'm going to say we go back to a pretty big negative slope. I'm going to go back to about -4. Okay, so now we're going to put all these together, and this will allow us to sketch our graph. At -2, I'm going to say the slope's about -4. At -1, I'm going to say that it was 0. At 1, I'm going to say the slope is about 1. I'm sorry, at 0, I'm going to say the slope is 1. At 1, I'm going to say the slope is about 0 again. And at 2, back to -4. So this is going to be a graph of our derivative. All right, part F. If the original graph above represents the position of the particle at any given time, when would the particle be moving right, left, and stopped? Okay, if this is the position graph that we are looking at right now, that means you need to analyze the slope to find the velocity. So right now, when I look at this graph and I want to answer the question right, I want to know on this graph, when is the slope positive? Because that will mean that my v of t is positive. And that's what we're looking for. For left, I want to know when the slope of this graph is negative, because that will mean that my v of t is negative. And then finally, when it's stopped, I want to know when the slope is equal to 0, because that's when my velocity is 0. Okay, so looking at this graph, we're going back. We are looking just at the original graph. I'm going to move this away for a second so we don't get confused. And we are looking just at this graph and wondering questions about its slope. Okay, so let's answer these. When is the slope of this graph positive? At x equals 1 to at t equals 1, -1 to t equals 1, this graph has a positive slope. It's increasing. So this would be t bigger than -1, less than 1. All right, when's it moving to the left? That's when the slope of this graph is negative. It's decreasing, i.e. has a negative slope from basically -infinity. So for t that is less than -1, all of the values of t to the left of -1, and also for t that is bigger than 1, all the time after 1. We're assuming this graph goes on forever. When is it 0? Well, it's 0 basically in between these. At -1, it's when it changes from positive to negative. So to go in between those, we would need to have a moment in time where we had 0 for our velocity. And also at t equals 1 for the same reason. All right, switching gears, part G says if the original graph above represents the velocity of a particle at any given time, when would the particle be moving right, left, stop, speeding up, slowing down? All right, so now we are answering the same questions, but we're talking about this graph as a velocity. So basically, this is the set of slopes. So when I'm talking about moving right for the velocity graph, I want to know when is it above the x-axis. because those are positive values. Okay? When I'm talking about when is it moving left, I want to know when is it below the x-axis, because that's where there are negative values. When is it stopped? I'm talking about when is it on the x-axis. And this is all because that would be zero values. This is all because now I'm thinking about this as an actual velocity graph. Okay, so looking at the original graph, when is it above the x-axis? It's above the x-axis for t values that are less than about negative 1.8. Let's just say this is about negative 1.8, so it's above the x-axis here. It's above the x-axis between 1 and about 1.8. So for t between, 0 and 1.8. That's when it's above the x-axis here. All right, when is it below the x-axis? Well, that's going to be all those other times that I've mentioned. So that's going to be between negative 1.8 and 0, and from 1.8 onwards, so for t bigger than 1.8. All right, when does it stop, meaning when is it on the x-axis? Well, that would be at these times in between. So that would be t equals negative 1.8. It's on the x-axis, 0, and then again at 1.8. All right, this question is asking us a little bit more. It's asking us when is the graph speeding up and slowing down. Speeding up is when v of t and a of t have the same sign. Okay, so when v of t is positive and a of t is positive. Okay, so let's look at this. Here v of t is positive, yet acceleration, the slope of velocity, is negative because it's decreasing, so not here. From about this negative 1.8 to about negative 1, v of t is negative, and so is your acceleration because the slope of this part is negative. So it's speeding up from about negative 1.8 to negative 1. Negative 1 to 0, our v of t is negative, but our acceleration, the slope of v of t, is now positive, so it's not that part. From 0 to 1, v of t is positive, and so is acceleration. So that would be from t bigger than 0, less than 1. From 1 to about 1.8, v of t is positive, but now the graph is decreasing, so negative acceleration. From about 1.8 onwards, v of t is negative, and so is acceleration, the slope of that. So that would be for t bigger than 1.8. These are all the times it's speeding up. When is it slowing down? That's when they have different signs. So basically that's everywhere we didn't just already mention. We started out by saying they had different signs here. That acceleration was negative here, so plus and minus, negative signs. So we've got for t less than negative 1.8, t less than negative 1.8. We have, this is negative in terms of velocity, but positive in terms of acceleration, so negative 1 to 0. And then finally right here from 1 to 1.8, velocity is positive, acceleration is now negative, so that's from positive 1.8 to positive 1 to 1.8.